Welcome to section 1.3. This is about data collection. Data collection is really important to understand for anybody going into a field where you're going to be looking at studies or research, any kind of psychology, social science, any of the healthcare industries are all going to care deeply about this because they are all created and decided based on experiments and studies, and how those studies are conducted really matters. And so we're going to look at some of the parameters for creating a good study. So the first thing that we want to talk about is two types of studies that we're going to look at: an experiment and an observational study. So an observational study is just what the name implies. You're just observing. You're just watching. You're not doing anything. So you're going to take a population of some sort and you're just going to look at it and make some kind of inference from just watching. An experiment is where you're actually going to do something. You're going to give somebody a pill, you're going to draw blood, you're going to ask them a question, you're going to have them run a mile, anything like that. So in math language, what we say for experiment is a treatment is given. So treatment is just a fancy word for like you're doing something to the population. And then an observational study is observe only. Now, I'm going to take a minute and talk about an experiment because there are several components to what and vocab words associated with the experiment that you need to know for your homework. Let's take an example if we are testing a drug. So I want to know if this pill that I've created lowers blood pressure. And so I'm going to run an experiment. I'm going to take a population of 100 people and I'm going to give them this pill. I'm going to measure their blood pressure before and after. Psychology has shown us that if the mind is really a powerful component of our body. If we think something is true, often our mind will convince us that it is true and our body will respond. So, for example, they've done studies that have shown that if I give you a sugar pill, but you actually think that the pill is medicine for whatever is going on in your body, that a lot of times your brain can heal your body. Like you think that it's going to heal you, and so you actually do experience healing, even though the pill was not actually medicine. Because of that, it makes experiments tricky, because what you want to do is you want to give one group of people the pill and one people not give the pill. That subset that you don't give the pill to is called the control group. And so the problem is that the control group will know that they're not getting the medication, and the psychology of that will influence the outcome. Whereas the people who have the pill, are going to think, oh, I'm going to get better, I'm getting medicine. And so that again will influence. So we do something which is called, we give people a placebo. And a placebo is a fake treatment. So in my example of the heart pill, I might give half of my population a sugar pill and then the other half the actual medication. And then they don't know that they're not getting the pill. And so that helps that mitigate that psychological issue. In addition, as the person running the experiment, I can inadvertently treat people different who are getting the medication and who are not. Maybe I'm giving more care to the people who have medication or not. And so what we can do in an experiment is run what we call a double-blind experiment. And a double-blind experiment is where the person taking the medication and the person running the experiment don't know who has the placebo and the real drug. So it's decided by either computer generated something or someone else that's not involved, and nobody knows who has the real medication. And then double blind allows there to be no psychological bias in that sense. So double blind is when no one knows who has the placebo. Sorry, I just realized that my writing is behind the picture there. Sorry about that. Okay, and then the other thing that's really important when you're running an experiment is that is replication. Replication is can you duplicate the experiment? Can you run it again? Is it able to be studied over and over? Because repetition in science actually adds more data and adds more reliability to the outcome. So those are some of the vocab words you're going to see in your homework. Now let's go to the different types of data collection. There's several different methods. The first method is called a simple random sample. So what happens here is everyone in my population gets numbered some way. And then I randomly pick my sample. And the way that we do that is with a random number generator. I'm going to show you how that works. Every time I do something on the calculator, I'm going to do class calc and then the TI. You can just fast forward through the parts of the video that show the calculator that you're not using. So as I'm in class calc, like I'm going to come over here, I'm going to do class calc first. If you're on a TI, you can just fast forward till you see me bring up the TI and then tune back in. So for my class calc people, the first thing that I need you to know is in the upper right hand corner, it's under my picture here, upper right hand corner, there's a calculator. It's right here. And if you click on that and change it to graphing, that'll give you more of the stats options. And the calculator resets and defaults to a basic calculator every time. So when you pull it up new, make sure you change that back to graphing. The next thing that you're going to do is go to stat right here. And then you're going to go to advanced right here. And then randint, that stands for random integers. You click on that. The nice thing about class calc is if you forget what you're supposed to put in the boxes, you can click on this little question mark right here. You click on that and it tells you what everything is. Now in this case, it's already written out here, min, max, and then number. But on some of the things we'll do throughout the course, there's nothing written and you're like, it's a blank box, what do I put in there? And that question mark will tell you. So what we do, let's say, for example, we have 100 people that we want to survey and we want a sample of 20. So I'm going to number everybody 1 to 100. So that means the minimum number is going to be 1. That's going to be my first person numbered. My max is going to be 100. That's how I've numbered them. And then how many numbers do you want? Do you want a sample of 20, 30, whatever? So if I want 20, then what you do is you tap on this 20 item list right here. So I'm going to tap right there and it's going to come up. So this is telling me you want to choose person number 59, person 32, person 63, and so on. And that's how you randomly generate numbers on class calc. You'll have to do that in your homework. On the TI, let's go down here. Yours could look a little bit different, but it should be similar to this. you are going to first go to this button right here. It says math. And when you hit that, there's going to be categories up here. And like the fourth one over says PRB. So that's PROB, I guess it is. PROB. That stands for probability. And you're going to use your arrow buttons, that's these right here, to go over and highlight that probability. And when you do that, you're going to have a list that comes up. Now I'm going to just jump over here. And here's your screen once you click on probability. And it's going to say 1, RAND, and then 2 is NPR, and then 3 is NCR. 4 is an exclamation point, and 5 is this rand int. And that's what you want to select. So we're going to go down to 5, and then you're going to hit enter. The enter is right here. That's how you select. And then this new screen comes up, and it says, what's the lower, what's the upper, and what's your N? And then it says paste. So the lower is what's the first number in your population. So if we enter 1 and then say we have 100 people, so we say I'm going to number people from 1 to 100. And then if I want N is how many people do you want in your sample. So let's say 20. And then you hit enter on the paste, and it will kick you to a new screen. And it'll say rand int, and then it tells you what you typed in, like this. You have to hit enter again for it to show you the list. Now, it'll have a little bracket like this, and it'll have 86, 98. You'll have different numbers than that, but this is what mine says, okay? It goes off the screen. You can't see all of it. If you hit enter again, you won't ever be able to see it. So don't hit enter. Hit the arrow button, this right arrow button, and that will allow you to scroll through that whole list, and you can see that you can access the whole list back and forth. But as soon as you hit enter, you can't go back and scroll through that list again. So be careful with that. You'd have to regenerate another set of numbers. So that's how you do the random integer on both calculators. There will be some homework questions on that. And then that's who's in your sample, those 20. Now, pluses and minuses. Positive, this is fully random. It's like there's no bias here. The deficit is that it's time consuming. And sometimes you don't want to take your whole population. If your whole population's large, you can't number them. Now, there's certain situations where this is really ideal. Let's say, for example, I want to study Allen Hancock students. Guess what? You guys are already assigned a number. You have an H number. So all I have to do is take all the H numbers, randomly generate numbers, and, or like I'm in a sports club. Sometimes your like key fob on your sports club has a number on it. So sometimes this is ideal, but in general, if I want to survey the whole United States, not ideal. Okay, number 2, our next method is a stratified sample. The way a stratified sample works is you take your population. I'm going to write just a square to represent the population, all of that, and you divide it into subgroups. And those subgroups should have something to do with what you're studying. So for example, if I want to know if this pill lowers my blood pressure, I don't want to take my population and divide it by whether they have a cat or a dog or hair color. That doesn't have anything to do with my study. What I want to do is ask myself, what matters? What kind of parameters matter? For example, maybe age is a factor in how this drug works. We know that, young people and old people have different metabolisms and different different things going on in their body. So maybe that matters. So for in this example with the pill, I might want to divide by age. I'd say like this group right here is going to be my 20 to 30 year olds. And then this is going to be my 30 to 40 and 40 to 50 and so on and so forth. And then for a stratified sample, what I'm going to do is I'm going to pick a certain number of people in each of these categories. So to equal however big I want my sample size. Usually bigger samples are better. And so usually I would be picking like maybe 20 people out of each category. So I have a big sample. But the idea is that it's the same number from each. What this does is it assures that I get an even distribution of people. If I took my whole population and didn't subdivide it, and I just picked a random 20 people, it's possible that I randomly get all of my people like in my 20 to 40 year old range, and I don't study any older or younger people. So the advantage of this method is that you may assure that you get a diverse population. Here's another way a stratified sample could go. I want to know people's perspective on dating. So I want to pick men and women, and so I might subdivide by gender. That's another way to subdivide, and then pick an equal amount from each so that I'm getting input from, I'm not getting like all men by random chance. So stratified is picking a parameter, dividing, and then picking a couple from each. Now, cluster sample, it starts the same way. You have this population, and you're going to subdivide it into different categories. The difference is with a cluster sample is that you're not going to pick some from each. You're going to pick all of a couple of them. So let's say we divide like this. I have these divisions. I'm going to pick all of these, all of these, all of these guys, and say all of these. So I'm picking certain groupings and serving all of them. Here's an example where I might use that. Let's say I want to know how effective the TI calculator is in a stats class. Or maybe I want to compare like TI versus ClassCalc. Who likes the TI better? Who likes ClassCalc? So my population would not be all of Allen Hancock because that's not everybody takes stats. It would be all of my statistics classes. So for a cluster sample, I might say, well, they're already divided into groups. They're divided into classes. And generally speaking, it is a random distribution. Now, there could be some biases. Maybe certain people take morning classes, evening classes. That would be up for discussion. But let's say, for example, that we just divide people by classes, and then I use my random number generator to randomly pick 5 classes to go survey. So then I'm gonna take this class, I'm gonna survey class number 2 and 5 and 11, and that's gonna be my sample. So I'm not going to every class. I'm just going to a couple, 2, 3, 4, but I'm serving everybody in the class. So the key word to look for with a cluster sample is somewhere in the explanation it'll say all. So I subdivide by blah, 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 and then I pick all the people in. That's a cluster sample, as opposed to I pick 3 in each category. That would be stratified. All right, next type of sampling is called systematic sampling. Systematic is surveying. We say in math, we say every nth person, or sometimes people use the letter K. All this means is that n can be any number you want. So like I'm going to survey every 3rd person or every 12th person or 10th person. This might be used, let's say I want to know who likes the hot dogs at the basketball game. So I might stand in the gym, and as people file through the snack bar, I might survey every third person and ask them, do you like the hot dogs? That kind of a thing. Now, this is really easy. All of them can be biased. Okay. All of these sampling techniques can be biased in different situations. Depends on what you're asking and how you're doing it. So here's another example. I could ask, who you think should be the next president and stand outside of a grocery store or a yoga studio and pick every fifth person. Well, there's certain people going to certain grocery stores. There's certain people going to yoga. There's certain, and a lot of times when you get people in a certain situation, they have similar values. So maybe I'm going to a high-end grocery store because I value the quality of food. Maybe somebody's going to a less expensive grocery store because they're valuing, they have a higher value for the cost. And those people often will align in different issues. So if I'm asking a political question in a situation that's not politically aligned, you can get some bias in that situation. Now, my hot dog example works because I'm asking them what they think of the hot dogs. They're at the game. Those are the people that are eating the hot dogs. But what if I went to the basketball game and surveyed them and asked every third person, do you like sports? That's a bias survey because of course they like sports. They're at the basketball game, probably, right? So a better way to ask that question might be in the middle of the quad. You might get every fifth person that goes through the quad, you may get a better sample with that question of who likes sports. So you want to be in a neutral location. The last, well, not last, but almost last is, oh no, this is the last 5. 1, 2, 3, 4, 5. Yep, is a convenience sample. And this situation is exactly what it says. It's convenient, and it's almost always biased. So this is not a good technique. And it's just something that works and is easy. So if I survey my math class to ask them, do you like math? That's a convenient sample, but it's definitely going to be biased. If I ask people in my, if I'm in FFA or something, and I ask them something about animals or anything really, you're not getting a diverse population. So in your sample. So a convenient sample is easy, but it's typically biased. It's just doing something that is not time consuming. So I've talked through a little bit in my examples of how things could be biased or not. Some of your homework questions are going to ask you what's a bias that might be in this situation. And I just want you to start asking yourself questions well, are there any commonalities? Do those commonalities matter? If I'm sampling all redheaded people, depending on the question, that might or might not be bias. You have to ask yourself, is there a tendency in that situation? If I break up the state of California by zip code and survey all of 4 zip codes about something, well, ask yourself, what could go wrong with that? Could it be biased, or is that legitimate? What if randomly I survey Beverly Hills, Silicon Valley, and San Luis Obispo? What if those are my random zip codes that I survey? Is there some bias there as opposed to some lower income areas? That as an example. So think through those. If you want to talk more about that, I'm around, and I will see you next time. Thanks for tuning in.